Hello everyone, here we have an interesting problem and we can solve it very quickly using the concept of relative motion. So let us see the problem statement here. In this direction we are taking up north. Here we are taking up south, and in this direction we have west, and let's say in this direction we consider the east. According to the problem statement, there is ship A. Ship A is moving westwards with a speed of 10 km per hour. It's given to us in the question. A ship B is located 100 km south of A. So from A we need to go 100 km south. Means, let's say we consider this distance as 100 km. Agree? It is 100 km south of A. Now here is the ship B. That ship B is moving northwards with a speed of 10 km per hour. So this is ship B moving at a rate of 10 km per hour. Done. We'll be solving the question using the relative motion. So we'll observe the entire problem with respect to any one particle. Let's say we want to observe the entire problem statement with respect to B. It means we'll stop B. We will reverse its velocity and give it to A. So I am reversing this 10 km per hour and giving it to A. So here is the extra component 10 km per hour. Now the problem will appear like this. B is at rest and the A will move along this straight line. These two components, they are equal. So the velocity of A with respect to B will be directed here at an angle 45 like this, 45 degree like this. You agree? Two rectangular components of a vector are equal. It means that vector will be directed along the angle bisector. Now, initially the distance between B and A is this much, the 100 km. After some time, the A reaches here. Then distance between B and A will be this. After some time, the A reaches here. The distance between B and A will be this. After some time, A reaches here. Distance between B and A will be this. A reaches here. Distance between B and A is this. A reaches here. Distance between B and A is this. What you see now, the distance between B and A is continuously increasing. There is a reason behind that. At this location, if you see the VAB, velocity of A with respect to B, and if you join this A and B like this, then VAB has a component in this direction, and this component of VAB is responsible for increasing the distance. You agree with this? VAB will have a component in this direction. This component will increase the distance. Even you can sense it here. Suppose at this location, if you check, the VAB was in this direction and you join them like this and you extend this line. Does VAB has a component in this direction? So this component of VAB will further increase the distance between A and B. And if we look here at this location, let's say, for this location, the VAB, does it have a component along this red line? That component is responsible for reducing this distance. Even you check here, this black vector, its component along this vertical line, its component along the south direction is directed like this, and this component will reduce the distance between them. So if we check carefully, distance between A and B at some moment was this, after some time it became this, after some time this, so on. When the distance between these two particles will be shortest? Correct. The moment when you can drop a perpendicular like this. At this moment, there is no component of VAB along the straight line joining A and B, because the component of a vector at an angle 90 degree to itself is always 0. Then this is the shortest distance, and after that the distance between these two particles is continuously increasing, and before that the distance between these two particles was continuously decreasing. So this is the D shortest. You agree with this? To get the better idea, I am making another diagram. Here is the distance 100 kilometer. Here is the angle 45 degree. We consider the particle B here. Initially the particle A was here. From B we have dropped a perpendicular on the line of motion of A, and this we have taken as D shortest. Agree? This angle is 90 degree. So this angle is also 45 degree. Done. Now, using the laws of triangle, we can even say that this angle and this angle, they are same. So the side length opposite to them should also be same. If this side length is D short in front of angle 45 degree, then this side length should also be equal to D short. Technically, do you agree with this? These two angles are identical, then the side length opposite to them should also be equal. Now I can easily use Pythagoras theorem in this triangle. Using the Pythagoras theorem in this triangle, this is 90 degree, and in front of 90 degree we have the largest side of the triangle. So I am writing the Pythagoras theorem here. D short square plus D short square, this square plus this square should be equal to 100 kilometer square. Done. 2 times D short square is equal to 100 kilometer square. Taking square root both sides, we will get the D short is equal to 10 by root 2 kilometer. Done. Now question wasn't asking the shortest distance. Question was asking the time at which these two particles will be at the shortest distance. So when A reaches up to here, we have to calculate this much time interval. At this time, the A and B will be at the shortest distance. After that, when A reaches here, the distance between them is actually increasing. Agree with that? So to obtain this time, we can easily do the calculation. Time is equal to distance traveled divided by the speed. How much is the distance traveled by A with respect to B? It is equal to D short, and D short we have obtained as 10 by root 2 kilometer. And what is the speed of A with respect to B? It can easily be solved. The VAB will be actually equal to root of 10 square, this square, plus this square. Agree? Using the vectors, if the two rectangular components of a vector are like this, its resultant will be 10 root 2 kilometer per hour. Now putting the data here, 10 root 2 kilometer per hour. This kilometer is getting cancelled out, and the time comes out to be 5 hours. So after 5 hours, the A and B will be at the shortest distance. Stay awesome. See you again.